In this video, we have a vector analysis, a warm-up exercise. U is a vector valued function. It's a three-dimensional vector field, a function of time t, where t belongs to the set 0, infinity. We want to show that the Euclidean norm of this vector squared is given by this formula, 2 cos hyperbolic 2t. That the derivative of the norm square is 4 times sine hyperbolic 2t. And the last two relationships, that when t grows to infinity, the norm of the vector valued function u goes to infinity, and also the derivative, the first derivative of the norm, goes to infinity. So we have the norm of u is the following: the x component squared plus the y component squared plus the other component squared. E to the power of t cos squared of 2t sorry, this is 1t here, plus e to the power of minus 2t plus e to the power of 2t sine squared of t. We can take common factor e to the power of t, and inside the brackets we have sine squared of t plus cos squared of t plus e to the minus 2t. Sine squared of t plus cos squared of t is equal to 1. From here we have e to the power of 2t plus e to the power of minus 2t, and this is 2 times cos hyperbolic 2t. Because cos hyperbolic of 2t is the sum of the exponentials divided by 2. So we take the norm, the Euclidean norm squared is this quantity squared, 2 cos hyperbolic 2t. Now we take the derivative of the norm squared with respect to t. So we take the derivative of the following function, 2 cos hyperbolic t, cos hyperbolic 2t. Of course, 2 is just a constant. I can take it out of the derivative. So I have the derivative of the hyperbolic function here. This is 4 sine hyperbolic 2t. Now we want to show that the limit of the norm square goes to infinity. So we take the limit as t grows to infinity to cos hyperbolic 2t. Cos hyperbolic 2t is e to the power of t plus e to the power of minus 2t divided by 2. So I can split the limit into two limits. Now as t grows to infinity, this goes to infinity, and as t grows to infinity, this one goes to 0 because it's an exponentially decaying function. Now we see the last one, the limit as t grows to infinity, the derivative of the function of the norm with respect to t. So it's 4 times the limit of e to the power of 2t minus e to the minus 2t. And here I have a 2 in the denominator. This one we can simplify this one and this one, and we have a 2. And then the limit of e to the power of 2t goes to infinity, and this limit e to the minus 2t goes to 0 as t goes to infinity. So the norm here goes to infinity.